Hi, Year 11s. We continue in Chapter 13 with the application of trigonometries. In 13F, we're going to look at some variation or worded problems that will involve angles of elevation and depression, and as well as bearings and its notation. So here for the first slide, we're going to look at the angle of elevation and depression. So you have those definitions in front of you with the diagram where the angles are annotated. Again, what you will notice is you will have your right angle triangles, and you will depending on the situation, you will use your knowledge on your the trigonometric ratio in the right angle triangle. Don't forget as well, you will also have to use other rules like sine rule and cos rules. So here's one of the first example. So have a read through it, pause the video, and the first thing you need to do is just sketch your diagram and annotate all the dimensions that are given. Let's continue. Also, with your diagram, it's a good idea, once you have annotated what you know, is to which is here your unknown is A, B, but annotate as well like X or D, whichever you need to find out. So you know those dimensions. We're going to look at that right angle triangle on the outside, or we can do the same on the inside. You can use the alternate angle. So that angle here, which is the depression, the angle of depression, that angle is the same as this one, as they are alternate. We use the trigonometric ratio, which is your tangent. We make AB, rearrange the formula to make AB the subject and determine the distance. Again, just make sure when you use your CAS calculator, make your angle, either your calculator is set in degrees or you need to add the degree symbol as well. And as it is a question, it's a good practice to write a sentence to just list the actual value. Okay. Another example. Again, just pause the video, get a diagram. If you can continue, just try to figure out the answer through your working out. Alright, so this situation is a little bit more tricky, so it's important that you get this diagram right. Just double check through the text where the values are annotated. The 166 degrees is calculated, so that shouldn't be on your original diagram. Here, notice you have two triangles, okay, and what we're trying to find out is the length HC, which is the height of the hill above the level of A. To do this first, what we're going to need to do is looking at the triangle ABH first. And what we do, well, first we determine the angles on the inside, so we need to have that angle B, which is 166, because this is a straight angle, and this is the third angle in a triangle, and we get that value of 4. Using a sine rule, we can determine BH or HB. That's what we get here, and then we need to move on to another triangle. Knowing that BH is common to two triangles, we're going to move on to the second triangle, BCH. Use the sine rule again, and we can determine the length CH or HC. Another application of angles is bearings. What's important here is straight north is your 0 degrees, and you always go clockwise. So any angle value will be given in that direction, going clockwise, so going in that direction. Those are illustrations of different angles. Notice, so for C, for example, the bearing of C, that is the arc in yellow, that's 210 degrees, and you don't need to specify the directions because by default the positive direction is going to be clockwise from straight north. Let's do a few examples. So look at this example, read it through, and again pause the video and try to make a diagram starting with your straight north. Alright, let's continue. So here it is. Once you get your diagram, you have your triangle, you will apply all the rules that you would know, well, any of the rules. So trigonometric ratio, cos and sine rules. So here, to determine the angle, we use the tangent. You evaluate the angle. Now that is the angle inside the triangle. We need to find, bring that angle back to a bearing. So we need to add what's on the outside back to the to the north. That is a complementary angle, and we add the straight angle. We get the actual value of that angle. That will give us the bearing, and to find the distance is just Pythagoras theorem. So then we can have a sentence that will give us the two answers regarding the bearing and the distance. Last example. So again, have a read through, pause the video, attempt a diagram as detailed as possible with all the information given to you. So there's a few numerical values that you need to annotate on your diagram. If for the vertices you don't have any letters, just assign a letter. Some of the letters will be already assigned, so you have A and B already by default. Place them on your diagram. Alright, so that should be looking like this. Correct your diagram. Again, from here, just pause the video and attempt part A and part B. Alright, we'll continue. Part A, to find the distance A to B. So you will need to determine your angle ACB, which is inside your triangle. So we have that angle here. As we need to determine AB, and we know now the angle that is opposite, the cos rule will be the one that you're going to be using, and you calculate it, and we get the distance from A to B. Now before you move on, again, because part B might be using the answer from part A, always double check your working out. So look at your expressions, make sure you have the correct values. Also check the expression that you type in your calculator. You don't need to retype it, just go back on the line and check that you have the right number of digits and the right number everything else, the steps, the operations, and the brackets if required. Also check that you set your calculator either in the right units or you have written the degree next to the angle. And to find the bearing, we need to use the sine rule. We express A as a subject or sine of A, and we get the angle A. And then to determine the bearing, again, it's from the north, so we need to subtract that from the 360 degrees, and we need to do the difference of that angle, which is going to be over here, to go all the way back to the true north, and we get a bearing that is a 356 degrees. So just be mindful, again, with bearings, it's a value that go from 0 to 360 degrees. Okay, so keep that in mind when you do bearing calculations. And that's it for today. See ya.